Hey, hello everyone. Today we are going to solve this problem of the day from GHG, nth Catalan number. So we have been given a number n and we have to return the nth Catalan number. So they are defining Catalan number n as the total number of valid expressions that can be made by using n pairs of parentheses. So this is not the definition of Catalan number. Instead, it is just an application of Catalan number. So Catalan sequence is a very powerful sequence, just like we have a Fibonacci series, and it is very useful, and we can make use of it directly or indirectly in many of the questions, and it is directly asked as a theoretical concept in many interviews. So it is very important topic, and the code is not going to be very big. However, the concept is very nice and you should know that. So the Catalan sequence is basically here it is also given. So 1, 1, 2, 5, then we have 14 and 42 and so on. So what Catalan sequence is actually, when we consider C of n, so let me comment it first, C of n, then it is actually equal to basically a summation. So let me write this like this, and summation of C starting from I and multiplied by C of n minus I, and then this I will go from 0 up till n. So n minus 1 so for example C1, so C0 and C1 are already defined. So C0 is 1 and C1 is also 1. Now consider C2. So C2 is equal to, so if we consider this formula, so it will be C0 C1 and then plus C1 C0. So now in a very similar way, C3 becomes C0 C2 plus C1 C1 and finally C2 C0. So okay, fine, it is like this and defined like this and all. So how do we make link to the number of parentheses and all? So as you can see here, this can be easily derived using DP, where we are making use of C0 or C1 for C2, and then to compute C3 we need C2. So this is very simple n square approach, where we will be storing C0 C1 and then computing C2 and then C3 from bottom to top, or we can also go from top to bottom. However, let's try and figure out how this is helping us in making the parenthesis. So when there is 0, so we have no possible the null set is also a possible one, so we consider it 1 by default. So also we have that 2 raised to the power 0 is equal to 1, so by that sense. And for if we have one pair, then we can just make this thing, right? Only one possible thing. Now if we have 2, so we have to make use of 2 pairs. Now if I take a bracket, so I fix one thing, and now I know how to make brackets using one pair. So we have already used one pair and we are left with one pair. So we can have one pair inside and 0 pair outside, or we can have 0 pair inside and 1 pair outside. So this will give me 2 solutions, that is this and this. So what we did here is we fixed a bracket and then made use of whatever is left. So we had 2 brackets in the beginning, we fixed a bracket, we are left with 1 bracket, so we can keep that 1 bracket either inside it or either outside it. So this is very similar to C0 C1 and C1 C0. So done it in reverse order. So here basically whatever is inside is coming first, and then whatever is outside is coming outside. So we already know how we can make how many number of pairs we can how many number of valid expressions we can make making use of one pair. Now just for another example, let's see 3. So for 3 again we fix our bracket, and then so here let me do this. So yes, now we start with the again from 0 to let's take it from 0 to n minus 1 as we had here the sums. So we have fixed our bracket, and now we have what number of pairs? We have 2 pairs left, so we can make keep them either inside or outside. So first of all, we keep 0 inside, and so we are left 2 with outside. Then we can keep 1 inside, 1 outside. Fine. And finally we can have 2 inside and 0 outside. So there are 3 types of things. And then we know that 0 can be made in only one possible way. So like making use of 0, we have only one possibility, and making use of 2 brackets, we have just calculated our answer as 2. So there are 2 possible combinations using this one. So let me write them as well, so it will be better. So for 0 comma 2, what we can have, so no bracket inside, and then both the possible ways to make 2 brackets, so 0 bracket inside, and then the second possible way to make 2 brackets. And in a very similar way, let me copy this and paste this, and we can have 1 here and 1 here. So we have to keep single bracket inside. So single bracket inside, there is only one possible way to make expressions out of one pair, and single bracket outside. So there is no second possibility using this combination. And finally we have 2 inside and 0 outside. So whatever we made outside our bracket, we have 2 inside and 0 outside. And again the second combination making use of 2 inside and 0 outside. So in total that makes it 1, 2, 3, 4, 5. So there are 5 valid expressions making use of these brackets. So this is how this Catalan numbers work. So let's start coding it as well. So we can have first of all we have to make use of modular expressions calculation. So const mod is equal to 1 e9 plus 7. Fine. Now next we can have a long int dp or maybe c, so that it makes sense with Catalan, and its size will be n plus 1. So this is for our pre-computation of like from bottom to top we will be going, and we will have everything stored. So it is basically tabulation. So now we already know c0 is equal to 1, and also c1 is also equal to 1. Now we start from by calculating our Catalan series from I equal to 2. So 0 and 1 we already know, and we will go up to I equal to n and I plus plus. So now we have for int j is equal to 0, and j goes from 0 to n minus 1. So for in this example, just replace everything stating n with I and everything I with j, every I with j. So basically we are calculating for each I. So for each I less than n, and then the j is going from 0 to n minus 1. So from 0 to n minus 1, and we will have then j plus plus. Now next step is going to be whatever the current value. So we are calculating the Catalan ith Catalan number, and it will be equal to the Catalan number itself. So basically if we are considering c2, so we will first add so I just need to predefine everything with 0. So it will start from 0, and then first we will add c0 c1 into our Catalan number. So c0 c1, that is c0, so c0 becomes j, and then what is c1? So I, here n becomes I, so I minus j. So j is 0, and if we minus 0 from 2, it gives me 2. So in coding terms it becomes I minus j minus 1. So yeah, okay, fine. Now next step. So here also we can have n minus I minus 1. Okay, fine. That is it. So we will first add c0 c1 into 0, then we will have some value of ci, then we go to j1, then we will add c1 c0 into ci, and we have final ci, and at the end we will have our value of c of n. So let's compile it. So it is giving me 42 as expected. Now next step is make modular calculation. So I'll just modular, make use of this mod, and still it is giving me the correct answer. Let's submit it. So yes, it gets accepted. So basically Catalan number is a very important thing that you should know, and you might have been using it unknowingly. So other applications can be give all the possible BSTs making use of n nodes, or the number of triangles that we can make by making use of n vertices. So you can go through all those examples that have direct application of this sequence, and it is very powerful one. So yes, so today's question was very small to code, but conceptually it was very strong, and hope you liked my solution. See you tomorrow.